than just cleaner skies and quieter skies. It really has the potential to change where we live, how we live. Oh my gosh, it's one of the conclusions I reached from reading a report that our guest here today, Darrell Swanson, had a hand in writing. And it's from the Advanced Air Mobility Group, which is a special interest group of the ADS. So Darrell, as part of that, why don't you kind of tell us about the report and how it talks to the rise of what you've termed the ELCC, and you can explain what that acronym is as well.
Right. Okay. So I'm Darrell. You can find me on LinkedIn, of course, and you'll find a link to the paper, which is Distributed Aviation, a New Economic Model for Electric Aviation. So it really came out of research that I've been doing over the last 3 or 4 years. Soon after the Uber Elevate paper came out, I was lucky enough, I was working at a company where we did a lot of route economics and route analysis. So I wanted to test the ideas of electric aviation or eVTOL operations in particular. So we had access to all these great data sets, OAG and Sabre data. So we were able to test where are these shorter routes which might have enough capacity. And through that work, we just found that electric aviation has real potential. As my research evolved and more fixed-wing electric aircraft started to come into the market, this whole idea of distributed aviation came to my head. And funny enough, it was part of Mark Moore's paper when he was with JPL back in 2008, which I cite in the paper. Although funny enough, I didn't read his paper when I was coming up with mine, but I'm really chuffed that we more or less came to the same conclusions. But the difference between our papers is that I dove more into the economic side of the equation to understand what is going to motivate people to travel on these smaller aircraft over these shorter distances. So that was the origins of the paper. I joined ADS Group UK, so they're a trade body in the UK, and they represent aerospace defense and security. So on the aerospace side, most of the tier 1 OEMs are in there. And they set up the AAM group just to bring together the industry and talk about it. And they asked me to write the paper up from a presentation into a formally written paper. So that's the origins of it. And we had contributions from Luke Bonnet, Samir Savani, and Harini from Airbus. And that's the evolution of that paper. So it's really just bringing together the whole concept of distributed aviation. And then the amazing thing was on the same day that we published that paper, NASA published their regional air mobility paper, which was fantastic timing. I couldn't ask for better timing because regional air mobility to me is a subset of the wider distributed aviation model, in that you get this wonderful connection between fixed-wing electric aircraft maybe taking passengers over the longer sector lengths, and then they can get on to either local green modes of transport at the destination airport, or get onto an eVTOL to take them off to their final destination, that last mile journey. But your question about ELCCs, so that's kind of a play on the low-cost carrier model. So in the UK, Ryanair or EasyJet or whichever your favorite low-cost carrier might be. But the idea is that they've been talking about getting into the electric aircraft range, and it's interesting for taking EasyJet, for example. They first started talking about single-aisle 100-plus seats aircraft, but they've been ratcheting backwards to the smaller aircraft just as the technology is maturing there faster. But I think they're also seeing the real potential for these thinner routes, which aren't being served by traditional hydrocarbon carriers because it's just too expensive for them. So that's what I'm predicting, the eventual rise of ELCCs.
Well, and there's a lot to dive into just with what you've talked about, and we will. But one of the things that just talking about the route part of it for a second, really what you're looking at instead of this kind of this hub and spoke is kind of more of a peer-to-peer type of approach, right? When you're talking about distributed.
Yeah, absolutely. And it's not the first time we had a distributed aviation system. We had a distributed aviation system back probably in the 30s and 40s when aviation was really starting to develop. And that was a combination of technical aspects about the aircraft. They weren't as powerful, obviously. They didn't have the range on it. We couldn't get the efficiencies out of the engines. but every major town had an airfield associated with it. So you would start to go off. And then as the airlines develop, they would start doing these multi-stop routes where they're taking passengers through. And what they're doing is they're chasing load factors. So they want to make sure that they're selling as many seats as they can. So they started from A, go to B, drop some passengers off, pick some passengers up, and go on. And they might do a nice little circuit around. So that's kind of a distributed aviation model. As we got better at extracting energy out of hydrocarbons, engine technology got more complex, which made it more expensive to maintain and operate. The engines naturally got bigger, and that just meant that aircraft had to fly longer distances. So that means that those airports, they had to suck up a lot of traffic around them, so their catchment area would increase significantly. So that these smaller airfields started to suffer, and that the traffic would naturally concentrate at the hub airports because it's hub economics. Big aircraft need lots of passengers, so that makes airports big, and they need lots of passengers just to pay for all the capital. So that's how it grows, and that's where the hub and spoke system comes in. But eventually, along comes Freddie Laker and sets up his airline on a low-cost model and starts flying from some of these smaller secondary markets direct point-to-point, offering direct competition to the hub and spoke model. So that's the evolution of distributed aviation. It's almost like we're going back in time, where these smaller airfields, of which the Regional Air Mobility paper identifies, there's over 5,000 of them in the US, and they desperately need the traffic. So this distributed aviation model allows some of that traffic to distribute away from the hub and spoke network to these smaller airfields where people have opportunities to fly direct. Because in the end, there's more small airfields that are closer to passengers' origins and destination than there are large airports with great surface access. So that's where we're going to see it. But everybody's a winner in that scenario, because the large airports, they can backfill with long haul routes where they can't, because they're serving some regional routes. So they make a lot more money off of long haul passengers. The small airfields win because they're getting much needed traffic. The passenger wins. They're traveling a lot less by road to their origin airports, and then from the destination airport to their end. The environment wins because if you're doing it on an electric aircraft, assuming sustainable sources of energy, fantastic. And yeah, everybody's a winner in that model.
Except for maybe the car people, or the car makers or whatever. I don't know. Yeah. Or those terrestrial-based type things, right?
Well, I think there's always going to be people that will just choose to drive because it's more convenient, or they have a lot of stuff that they have to carry. Some of the demand modeling that I'm doing now, we're looking at maybe 1 or 2% capture of certain markets between different city pairs. So it's not a huge amount, but that 1 or 2% actually is quite large. It means multiple daily frequencies between some of these various destinations that we've looked at. And it starts to add up to a lot of time that people get back into their lives, and a lot of money gets put back into the economy because of it.
Yeah, and I was kind of being cute with my comment there, because what you're talking about really is about growing the pie. But one of the fundamental assumptions in this that makes it all work is just the reduction in operations cost of going electric. I mean, George Bai just said he's predicting 20% the operating cost for his electric 7-seater.
Yeah. Well, I think that absolutely feeds right into the rise of electric low-cost carriers. So in theory, the capital cost is a lot less because it's an electric motor. It's basically just got one moving part. We have all the distribution systems and that we have to worry about, but it's still a lot less costly than the hydrocarbon engine, a lot less maintenance, lower operating costs, as you are saying. So those cost savings can be passed on to the passengers. Not necessarily in the early days. I would imagine when there's lots of demand and very few aircraft, they'll make their money, and that's fine. That's what pays for the rest of the system. But what the operators are, or what I predict they'll do, is they'll try and keep their load factors high, because on a small aircraft, you're more sensitive to empty seats than you are in a large aircraft. So a 60% load factor on a 7-seat aircraft, that there's a lot of empty seats there that you need to fill up, versus a 100-seat aircraft. you can make it up with yield management in terms of the fare structure. So I think the economic pressure is to try and fill the seats to drive up your occupancy, so you're not flying deadhead operations, and that's what's going to drive us towards a low-cost model.
Well, especially in the beginning, if you have a pilot in there and you have people in there, and that's one of the questions in your modeling. Are you assuming that there's onboard personnel, whether that's a steward or a pilot?
Yeah, so I think automation is the future. It's just going to take us time to get there. In the early years, they will be piloted. Hopefully, depending on the aircraft size and the rules, you can get away with one pilot up to a certain number. I think it's 19 seats. You might have to have two pilots. But then we start moving into a phased transition of pilots out of it. So pilots become more systems operators, and then eventually we'll go completely autonomous. But that's just going to take us time for people to get used to it. It's a scary concept. But we have autonomous systems in current commercial aircraft. Some of the smoothest landings you'll ever have in a large aircraft have been done on autopilot. You definitely know when a pilot's pranged it into the runway and you have a bit of a rough landing, you can almost bet that was a pilot landing and not the auto pilot system. I'm going to get a lot of hate mail now, but that's been my experience. But yeah, and then obviously once you get the pilot out of the equation in terms of the cost, that makes it a lot cheaper. Now, whether or not we have to have somebody in there to help manage passenger behavior or make sure everybody's buckled up in their seats and not moving around during critical times, that's something for the regulator to sort out. I think we will have to have that for a good long time. But again, it depends on the size of the aircraft. But the other interesting factor that a lot of people don't talk about, which is a bit of a sensitive subject, is that the range of these aircraft is probably going to be limited not by how many electrons you can pack into it. It's actually going to be the bladder factor. Yeah, exactly. So what it's like. You have a couple of extra coffees or other beverages of your choice. You don't want to necessarily be going for a couple of hours without access to the privy. So that might be a bit more of an interesting thing. The solution, maybe go faster, but again, that brings in different aerodynamic challenges. And I'm not an aerospace engineer, but I understand a little bit. So it's all to play for.
Hey, just to be clear, in the model, in the paper, you're assuming that there's pilots only, though?
Yeah, absolutely. I'm not making any judgments on whether you should or shouldn't.
Right, but just from an economic standpoint, that's your baseline.
Yeah, my basic baseline is that they will be piloted, but that's going to be a function of regulation. But as soon as we have the systems and they're proven to be safe, absolutely, the economic incentive for the operators is to go pilotless.
Well, and that just I guess puts your paper on another line, economic line, and shifts it, right?
Well, absolutely, and in terms of capacity as well, it really changes things. So you think about a vertiport, and we make assumptions on how many movements per hour you can do based on a piloted approach and getting into ground effect and landing it and then getting off of it. But once you have an automated system, you're able to tighten up the whole system so that you have less separation between them. So you can really start to ratchet up the volume. And so these are some of the questions or things I'm telling future vertiport owners and operators or local authorities through my work with CAMI to look out for, is whether or not they have assumptions for full automation, because that's going to make a step change in the capacity of the facilities that they're building. So if an applicant comes in and says it's going to be this much capacity under today's technology and tomorrow's technology, when it's autonomous, all of a sudden it's here. And that delta can be quite significant when you're looking at the impact on the local transportation system. So we have to build that kind of thinking into the infrastructure equation.
That makes sense. One of the things you kind of touched upon just in the discussion was the whole idea of frequency, and that was one of the things that stood out was that something like in your pairing model, 47% of the frequency were like 250 miles. I figured it was between here in Bakersfield, Silicon Valley and Bakersfield, and then 90% were between here and Portland, if you will. Silicon Valley and Portland. So why don't you talk to that for a moment?
Yeah. So some of the original research we were looking at was where are airlines actually flying these aircraft? What are the sector distances? And that chart that I show in the paper really focuses on that 1,200 kilometers or what 600 mile type range. And yeah, at about we would say about 200 nautical miles or the equivalent there, 47% of the frequencies are actually covered. It just like that's where they peak out, and then you start getting that tail distribution in the curve. And then when we get out to about 1,000 kilometers, you're about 95% of the total frequencies offered are covered. And it said to me, it really spoke to me that regional jets and turboprops are built with more and more range and more seat capacity, yet the airlines are actually flying them over very short distances and not utilizing the full capacity of the aircraft. And I had a chat with Ken Schwartz about this prior to the paper being published, and he was saying, well, it's a function of payload of fuel. It's how much fuel you can carry. It gives you the option for the range if you want it. And a long time ago, a lot of aircraft manufacturers assumed that they would be tankering fuel because it was cheaper to carry the fuel somewhere else than fuel up somewhere else and bring it back. Those economies don't really exist today because most airlines, they hedge when they purchase fuel. So they buy it at a certain rate ahead of time. So they're a lot more efficient. So those arguments don't really come to bear anymore. So the question is, why are we not making aircraft which are fit for purpose? And along comes electric propulsion systems, and those ranges are available to us in electric aircraft. The X factor is going to be recharge time, but we're working on some amazing technologies that will hopefully address those in the next few years.
Yeah, and I just think, again, back to, and I apologize that I have such a US-centric focus, but I just think of all the mid-sized cities, maybe 25,000, 50,000 people that aren't served in those kind of rate. I mean, it's huge.
Yeah, absolutely. And I think if you just take a look at population distributions across the US or Europe, or just even thinking about the UK, with a 200-mile range, you can serve a huge number of those populations, and that's actually the next part of the business that I'm getting into. So I'm developing a demand modeling capability for advanced air mobility, and the reason for that is that a lot of like we've had the McKinsey's reports, we've had all the various different big five management consultancy firms give us the value of advanced air mobility in 2020, 2030, 2040, 50 billions and trillions. But nobody's really done bottom-up demand modeling. So coming from companies that do that, and with my partner, Jarek, at Avio Advisory, we're developing this demand modeling capability based on some unique data sources that can really help us understand where the demand for traffic is, what mode of transport they're using, what time of day they're doing, what kind of a traveler are they? Is it for work? Is it for leisure? Is it other purposes? And then we can start to use QSI modeling, which is a quality service index tool, to actually determine what kind of market share electric aviation could get out of that. And we're looking at some really interesting numbers that just speak to that study that I presented in the distributed aviation paper. Now that paper was just on 15 potential routes in the UK, and it was presented to DFT, who were very happy with it and have asked lots of questions about it.
DFT?
Sorry, the Department for Transport.
Oh, okay, thanks.
Right, another acronym. So that was presented to them as a concept paper on how we could model what the potential for electric aviation is in the entire United Kingdom. And one of the routes, I can't name the name of the route, but it's London somewhere. We would have 184 daily frequencies each way in a small eVTOL aircraft. So it's those kind of numbers which would allow an investor, either an infrastructure or an operator, to invest in buying vehicles. So it's actionable intelligence. And the next part that we're adding on to it is actually a scheduling tool. So again, we can tell people how many aircraft, when they would be flying, what's the power requirements, because that's going to be very important for utilities or cities or infrastructure owner operators. Again, the whole idea is to enable those investment decisions. And infrastructure right now is our biggest bottleneck.
Well, and one of the things that I found interesting is that you looked at the pairings between airports in England and found that there was only like 11% pairing currently, right?
Yeah, so that comes down to that economic analysis of hydrocarbon aviation. So to me, what it said is that there's a lot of airport pairs out there, and there's about 1,800 potential airport pair combinations in the UK for, I think it's about 61 airports that are licensed for operations. But not all of them are viable for hydrocarbon aviation because the cost is here for them to do it. And by the time they put their profit onto it, it's just too expensive for the average person to be able to afford that, or even business travelers. But with electric aviation, if all of a sudden the costs are 20%, then all of a sudden these routes which are uneconomically viable for hydrocarbon aircraft become economically viable for electric powered aircraft. And so that's the real interesting bits, is where are these routes? What are the other modes of transport that you can take? Is it road, or is it rail, or is it a ferry? And where can you put on these electric aviation flights, either eVTOL, where they have the range, or fixed wing electric aircraft where they don't? And that's just the power of the economic model. And this is why I think for those shorter haul trips, so what I'm calling sub-regional, or NASA calls regional air mobility, that's where the economics are going to play out. And that's the exciting bit, because we're reinventing commercial aviation at the sub-regional range. Although it's interesting, aviation, as you know, loves an acronym. So I called it sub-regional aviation, SRA. As NASA calls it RAM. So I kind of think RAM wins over SRA, but anyway, que sera, sera.
Very good. So I guess there will be, if I read this properly, there will be a little bit of a way to kind of test some of these assumptions with the Orkney Islands project. Yep. And tell us where the Orkney Islands are. I had to do a little research myself.
Yeah, so that's far in the north of Scotland, The issue there is public service obligation flights, and lots of countries around the world have these flights where the government subsidizes these trips, because otherwise they would be remote communities completely cut off from the rest of the world. Scandinavia has a huge number. Norway in particular, they have a lot of public service obligation flights. So these are flights that are subsidized by the government. They're not 100%, they're not free. The people still have to pay a fair price for it, but it is subsidized because we just recognize that there's no other economically viable way of getting passengers back and forth to the mainland. And there's lots of social benefits that are associated with doing that, plus economic benefits as well. So it's in the government's best interest. But the idea is electric aircraft with their lower operating costs could either not need those subsidies or require a lot less of those subsidies to do it. So I think in the UK, the last figure I looked at was about £13 million was paid to airlines to subsidize their operations. And it is possible that we could almost get rid of it. And that, again, 13 million is not a huge amount for a government.
Right. But it starts to add up over time, right?
That's 13 million that can go straight back into the economy, allow more frequent access to larger populations for social interaction or for jobs or whatever. And it has huge societal benefits in doing that. So again, this is one of these things that electric aviation can help us do.
Is there a planned trial or anything to try that, or?
Yeah, there are trials up in the north. I'm not. It slipped out of my mind at the moment, but there are trials which are planned. I know that the Norwegian government have a few different programs underway, and I know that they'll be rolled out around the world, because if you're a government, you're looking for ways to save money, and it absolutely makes sense to investigate and support them. In the UK, I was going to say we have the Future Flight program, which is sponsored by UKRI, so the UK Research Initiative. And the Future Flight is about investing in systems and processes and whole systems of systems to enable electric aviation systems. So we're actually going to have the world's first Vertiport in November through one of these competitions. The competition that I'm working on is the Skybus project. Hold your breath. It's a large eVTOL concept. It's 30 to 50 seats. So this is a big aircraft. But we're investigating what the use cases are for that. So one of them is the chief one we're looking at is something called Mind the Gap. So if you've ever traveled in London and you're on the underground system, you're always hearing mind the gap. So mind the gap between the curb and the train. But there are gaps within the transportation system where it's difficult to go from one part of London to another because of the radial nature of it. So again, we're looking at a PPP model, public-private partnership, where instead of TfL investing hundreds of millions in a new tube line or whatever, we could partially fund a large eVTOL concept to help passengers make those trips. And one of those trips would take over 2.5 hours, require 3 different tube lines that you'd have to change on, and 44 stops along the way.
Wow.
So mind the gap, or let's plug those gaps in the system. But again, this is where governments invest in these kind of programs.
I would imagine it could be a much lower cost alternative than, if you're trying to build another tube to kind of bridge that radius, right?
Yeah. Absolutely. Tunneling, you're looking at millions, either dollars or pounds, or it doesn't matter what currency it is. Right. It's millions per kilometer, tens of millions per kilometer, in fact, for tunneling. So you could definitely save on that. It's about finding those right pairs that make it economically viable. So we're looking at the use cases. I'm looking at the concept of operations. I'm working with Pascal and Watson on what the infrastructure requirements are, and it's a big beast because we have the Skybus project that would be there, but we're also opening it up to other smaller eVTOL concepts so that it makes the best use of the space. But that's just expensive. But it's a commercial model that you have to make work for itself. So that's some of the fun stuff that I'm doing.
Are you looking at it as kind of a multiple use type of facility as well, beyond just transport?
Yeah, no, I absolutely. So the part of some of my presentations, we talked about the Waterloo concept, I think last year.
Yeah, in London.
So the Waterloo concept was about a multimodal transport hub. So it's trying to make sure that you're making the best use of public transport systems. And one of the concepts is something that's on the edge of the Thames. So we would have water taxis or water ferry type operations. It's close to one of the London rail stations. So you would have access to the underground line and heavy rail, and then the bus network as well. But then we also focus a lot on micromobility, so scooters and e-bikes, and we're looking at what those business models might look like to try and maximize their utility. I was a bit shocked. Lufthansa Innovation, they published a chart the other day showing that these dockless e-scooters actually have a pretty high carbon footprint when you look at it on balance, because they're very short-lived. So you have to count the carbon that goes into making it.
Right.
So I'm rethinking that, and I'm actually thinking, well, maybe if we make them docked and we actually tie it in with the pass that the person has, so that they have an e-scooter at home, they charge it up, they bring it to the origin Vertiport. They just charge up there. It's waiting for them when they come back, and then they pick one up on the other side, so that we get a higher utilization rate, so lower carbon cost associated. So those are the kind of systems thinking that we're putting into this project.
The other thing that I find fascinating about this, I was thinking about this as you were talking about the idea of connecting those points that otherwise wouldn't be very easily connected. When you look at the total carbon cost of that versus, say, building a rail line, there's a lot of fixed infrastructure in one versus other. Seems to be much more built on demand type thing. No,
absolutely, and that's the nice thing about aviation, in that you haven't got any fixed infrastructure other than at the origins and destinations. And then once you have additional destinations, the number of pair combinations goes up significantly. So you have discrete infrastructure investments, but you have incredible variability in terms of the routes that you're setting, and that will be set by demand, of course, and that's why I'm doing demand modeling. But for this mini study that we did, just on the 15 routes, and we only had a week's worth of data that we could purchase. But when we annualized the number, we figured that just on car journeys alone, we calculated on an annualized basis that we would save 80,000 tons in carbon emissions just on those 15 routes. And those aren't by any way representative of how many potential routes that we could actually put on. We didn't calculate it for rail, but we know that there would be significant carbon savings with rail. But it just speaks to the environmental credentials of electric aviation. Of course, that's assuming that you're getting the electrons or whatever your power is from a green source. Questions about hydrogen, whether it is truly green, depending on how it's produced and where it's produced. And you really have to look at the entire
food
life
chain
cycle of the energy. But we're moving in that way so that we can reduce the miles traveled by cars and reduce those carbon emissions.
Well, yeah, and that's a good point. If you can get that origin destination closer, you know, again, I keep going back to that train thing because I'm thinking of the France band. I'm going to ask you about that in a second. But back to this, I mean, you know, the rail, you're like here, but if you still have to get to here,
yeah,
are you going to be driving in an internal combustion engine car? Are you going to how you get that point, right?
I think that's something that the infrastructure investors and the operators really have to look at. So you have and this is what we do in aviation. So I'm an aviation infrastructure planner. So I look at where people are starting their journeys, how they get to the airport, how they get through the airport, fly, and then get to their ultimate destination. So when you actually look at the end-to-end journey, it's actually a lot longer than people will say, well, the flight is only this long. Well, the flight is only a relatively short part of your actual journey,
right?
Or it can be significant. But for these shorter journeys in electric aviation, that first and last mile are incredibly important. So this is why I firmly believe that we have to try and get people onto green modes of transport. Now, whether it's an electric car or an electric car share type deal, or micromobility, a bike, or your Mark 1 feet, that's what we're trying to do to get you there in green modes of transport as much as possible. So we want electric aviation to be born green.
So it does get you closer to where you want to be compared to other.
Well, yeah. So that's the nature of the hub and spoke system. I think the regional air mobility paper that NASA does talks about there's about 7 or 8 major airports, major hub airports across the U.S. That control 70% of the traffic. But that just means that the catchment areas of those airports has to be huge, and that's why they're investing hundreds of millions in rail systems to service them. It's staggering the amount of investment that you have to do to support that model. And this is where a distributed aviation system could allow us to distribute some of that demand out to the smaller airfields that are closer to origins and destinations of people where they really want to go, and allow you to make that journey choice.
Well, and so that leads me to the France question. I mean, I think they banned by a certain date some aviation flights. Why don't you tell us about that ban?
Yeah, so my understanding of that is a law was proposed in France to ban certain flights where you could take it by rail. And I can understand the logic of that. And when I was doing a lot of acquisition due diligence and we would get into the forecasting, you're always looking at other competing modes of transport. And in Europe, they have a very good high-speed rail system. In the UK, we have some really good high-speed routes. So London, Manchester, London, Birmingham, Birmingham, Manchester, of course. So you're looking at how much traffic you could bleed on to those other modes of transport. So some lawmakers there have suggested that for routes where you could take a rail journey, you would be prevented from taking a flight. I have questions about how you would actually go about policing that kind of a system, because you would almost have to have some kind of a rule-based system where you have to go onto a website and say, this is the journey I want to make, and then it recommends you can take road, rail, or an airplane. I have a challenge with how you would do that from a law point of view, but I appreciate what they're trying to do. But I think in the world of electric aviation, that becomes a bit more of a moot point. Because if you're able to travel on a green aircraft, assuming, again, energy source from green sources, you don't necessarily need to do that. And if the other savings that could come out of it is that if you ban certain flights, you could have to put on more infrastructure as a government to handle that additional demand that you're pushing onto rail, so either more rolling stock or additional train lines. And we just know how capital expensive that is. Whereas you can use an existing small airfield, shore it up a little bit in terms of a bit of capital investment, support green transport to and from the airport, and hey presto, you have an immediate demand for traffic that wants to do those kind of trips, and at an affordable cost, probably price competitive with rail.
And probably in the beginning, it would have a lot less greenhouse gas in terms of like comparing it to building a new rail or whatever, right? I mean, if you had to build a new line or even rolling stock, it's pretty intense,
absolutely. Right? The carbon embedded in those systems is absolutely huge. There's obviously carbon embedded in the entire electric aviation system. So the great thing is we have an existing set of airports. So the carbon's already been spent in building it. It's not been utilized effectively. So this is the opportunity for us to utilize that carbon that's already been emitted. But in terms of even the rolling stock, there's a lot less carbon produced in the production of an aircraft than there is in, say, a passenger car for a train, or a motor unit on a train, so the train engine itself. So somebody's going to pull me up on that, but I would suggest that there's probably a lot less carbon. Of course, we have the issues of where do you get the lithium from, and the rare earth minerals that are going into it, but hopefully lithium sulfur batteries are a technology that will evolve and solve part of that problem. But yeah, absolutely. An aviation system is distributed by nature. It can be a lot lower cost and save us having to make some of those other investments.
Well, that's why I kind of wonder if it seems like from a political standpoint, just there doesn't seem to be a lot of awareness of where electric aviation is, that it's on the cusp of some major things. And yet it seems like politicians aren't, in that mindset yet.
I see it maybe from the other side, obviously, because I'm up over my head in it at the moment. So the U.S. Definitely is ahead of the curve in terms of the government program. So NASA is always.
Oh, NASA, yeah, sure.
Yeah, Agility Prime, fantastic program.
Right, Air Force.
The Future Flight Challenge out of the UK was the response to Agility Prime in terms of trying to bolster things in the UK, and the UK has an amazing aerospace history. Other countries around the world are doing it. So France is trying to do it. They have their choose Paris region. I know that the Italian government is looking at it. There's some across Europe in the Horizon 2020 programs. There are, but I would probably suggest that there's a lot less perception from the wider public about electric aviation. So we're starting to get that, and that's probably been driven more by Joby and Archer and the SPACs that they've recently had, and the SPACs that they just raises their profile all that much more, because it becomes an investment, and people more attuned to where are they going to invest their money. Oh, this technology has come along. Oh, wow, this is interesting. Let's get into it. But a big piece of what we're trying to do within the industry is raise the public awareness of electric aviation. And so this is where organizations like CAMI, so the Community Air Mobility Initiative, and Flight Crowd, which is an organization in the UK that's trying to promote electric aviation to the wider public, that they're trying to raise awareness so that we can get a better understanding. Part of the distributed aviation paper was written to inform government, and there's another smaller paper that will be lobbying government with to raise them or raise their awareness of what the issues are and how electric aviation can help. So we're trying to feed back into the government funding process so that we can secure more investment from government to invest in these programs. Because again, everybody wins in a distributed aviation model.
Yeah, and you may have touched upon it. Perhaps the general public perception, and maybe even the politician levels, not necessarily the government agencies, but a lot of them have this more as a Jetsons type thing versus the next generation of aviation type thing.
I think the Jetsons is something, well, people my generation, maybe your generation, always looked at when we were kids.
Yeah, yeah, dating us, aren't I?
Yeah, it looks great, but I don't think the Jetsons is a reality. It's not a reality that I think we should necessarily strive for. All these vehicles flying all over the place. I think society will have natural limits to the number of vehicles that they want to see in the air and possibly here, because until we develop some kind of an anti-gravity system, we're still going to be using Bernoulli to get lift to fly, and that's going to make noise, and people will have an aversion. Electric aviation will be a lot quieter than hydrocarbon aviation, and just the demonstration that Jobin did with their J4 was absolutely fantastic. But again, that aircraft had no payload in it, and so you put 4 people on that, it's going to get a little bit louder, but still, it's a very quiet aircraft, and we can achieve that. So there's going to be a balance that society will accept, and I think that balance will be determined by politics and the region and the economics of it. So some places like, say, Sao Paulo, where road congestion is just so bad, public transport is very difficult, they'll be more accepting of electric aviation, whereas London may have a lower value placed upon it. So we will see less frequency, but that's just going to be depending upon where you are in the world.
And one of the things to kind of leave with is that you had a kind of a timeline in there, which seemed like a very realistic timeline for how this market develops. And, what do you see as the challenges to, that timeline as far as what will either make it happen or, roadblocks potentially? I
think that depends on what point of view you have. If you're an OEM, you're looking at battery technology. That's one of your key barriers, and obviously the regulatory process. But I think regulation and technology are things that can be solved with time and money. And as we've seen with the recent SPAC activity, money is available. It's just a matter of getting time and getting the regulator happy with what you're doing, and then getting the certification process. The money also solves the technology problems. So there's some really interesting battery technologies out there. So I've mentioned lithium sulfur or solid lithium batteries, which has real potential to make these kind of trips viable. We got to get them off the bench and certified and tested. Again, that just take a little bit of time and money. I think if you're a government, you might be looking at noise and how it actually fits in with the local population. So I was just reading the London plan again, which has been adopted, and it's very anti-helicopter and anti-aviation almost. They recognize the importance of it, but they oppose the development of airport capacity or additional runways unless they can offset the negative impacts, and a lot of that's noise and carbon emissions. But electric aviation could get around that. So I think governments could get in the way of a good investment unless they understand what the issue is. But then from the social side, it's really that social acceptance, which comes down to noise, because unless you're hearing impaired, it's the one thing we all have in common. We can hear these things and we all have an opinion on it. So we need to do a big piece in educating the public about what the noise is, and we need to be a lot more transparent than the airport industry traditionally has been. We've handled it badly over the last 20 years in terms of talking about noise footprints and how noisy it is. People can hear it. That's what they're talking about. So we need to change that conversation. So this is what Flight Crowd and other organizations are doing. But then it's getting the social acceptance through ensuring that more of society is able to access this mode of transport. It cannot be something for high net worth individuals only. So that means that we have to bring the price down to a point where more of society is able to enjoy the benefits of this electric aviation system. And again, that's where a low cost model comes into it. Like I said, I think all these factors come together, maybe not the technology one, but that's what's going to limit how many vehicles you'll see in any one region or area. So yeah, it's an interesting one, but that 15-year time path, I don't see any significant barriers to getting there as long as the industry gets its act together and addresses the technology, addresses the regulation, certification, and really starts communicating with the wider public. And probably the last two, the noise and the social acceptance in terms of the cost. Those are the two bits that keep me up at night, because that could kill it faster than regulation, certification, and poor technology.
Yeah, the nice thing though is that it isn't kind of this revolutionary thing where it's a step function. It is building off what's already there.
Absolutely, and that's a great theme of the regional air mobility paper, is that we don't need individual technologies or multiple technologies to mature at the same time for it to happen. It is happening now, and every step that is delivered into the system, it just makes the system all that much more viable, and that's what's going to accelerate the acceptance of a regional air mobility model, and eventually the distributed aviation model. Urban air. So people talk about, well, do we need UTM? So unmanned traffic management. I've heard it called out of 6 or 8 other things, but air traffic control effectively for eVTOL. Well, we don't need it today, because even if Joby and Archer and Wisk were to be certified now, and they had production of 30, 50, 100 vehicles a month, there's not that much production capacity. And even if you put it into the LA basin, there still wouldn't be that many aircraft that you couldn't control it with the existing systems that we actually have. There's enough capacity out there in the system that we can handle that scenario, but it's not going to happen that fast. It's going to be drip feed into the system. And then eventually these autonomous air traffic control systems will come into play, and we'll just naturally walk into it. It'll be a natural progression.
That makes sense. Well, Darrell, I appreciate catching up with you and giving me the update here. So thank you very much.
Brilliant. Thank you very much. Looking forward to it. And let's try not to make it such a long time for our next chat.